So when you look at the skyline of Riyadh, Saudi Arabia, there's one building you just can't miss, right? The Kingdom Center. That silhouette is totally iconic, but look closer. Right at the top, it's got this massive hole, this huge void. And you gotta wonder, what's that all about? Well, let's dive in.
Because let me tell you, that hole is not just there to look cool. It's actually a brilliant engineering bypass, designed to handle a skyscraper's absolute deadliest enemy.
And that enemy? Yeah, it's the wind. You see, every tall building has to be designed with a bit of flex, a little give, because they are in a constant fight against the sheer power of the wind. Engineers have a name for these forces. They call them wind loads. And here's the crazy part. The difference in wind speed as you go up is just dramatic. I mean, you could be walking down on the street and it feels like a perfectly calm day, maybe a nice little breeze, but you go hundreds of meters up, that nice little breeze turns into a relentless, ferocious force that's just hammering away at the building. Okay, but it's not just about the raw strength of the wind, like a big bully pushing on the building. No, the real threat, the thing that keeps engineers up at night, is this wild aerodynamic thing that can happen, something that can literally make a skyscraper dance itself to pieces. It's a phenomenon called vortex shutting, and you've actually seen this before. Just picture water flowing around a big rock in a stream. You know those little whirlpools, those swirls that peel off the sides? Well, believe it or not, the exact same thing happens with air when wind hits a skyscraper. These really powerful swirls, called vortices, start forming first on one side of the building, then the other. Now, these vortices don't just spin off into nothing. They're actually really powerful. Each one creates this little pocket of low pressure right up against the building. The best way to think about it, it's like a suction cup, literally pulling on the side of the tower. So here's the key takeaway, right? You've got these little suction forces popping up, first on one side, then the other, back and forth, over and over again. And this constant rhythmic pulling is what causes the whole skyscraper to start swaying. And trust me, that's not just uncomfortable for the people inside, it puts a ton of stress on the entire structure. But that gentle swaying, it can escalate. And it can escalate into something way, way more dangerous. It's a scenario, a trap that engineers are absolutely terrified of. A situation where the building's own movement becomes its worst enemy. This is a little something called resonance. And the best way to get it is to think about pushing someone on a swing. You know how if you time your pushes just right, perfectly matching the rhythm of the swing, it goes higher and higher with every single push. Well, it's the same idea. If the rhythm of those vortices hitting the building perfectly matches the building's own natural sway, boom, the whole effect gets amplified like crazy. The result? The building starts to oscillate violently. Each sway gets bigger, and then bigger still. It's feeding on its own momentum. And if it keeps going, you're looking at catastrophic structural failure. Yeah, the building could literally rip itself apart. So that's the big one, isn't it? The billion-dollar question. If you're designing one of these megatowers, how on earth do you stop an invisible force of nature from tearing your building down? Well, the answer is surprisingly simple and kind of counterintuitive, actually. Instead of just building a bigger, stronger wall to fight the wind, you do the exact opposite. You open it up. This idea has a name. It's called the porosity principle. The whole strategy is to stop fighting the wind head-on. Instead, you make the building more, well, porous. You literally cut out parts of it to let the air flow through the building, not just around it. And that brings us full circle, right back to where we started. This whole principle is the secret weapon that's hiding in plain sight, right at the top of the Kingdom Center. So yeah, that giant hole, it's not just there for decoration. It's a total masterclass in using the porosity principle to solve a huge, huge problem. And the real genius is where they put it. The engineers stuck that gap right at the very top of the tower, which is the exact spot where the wind is at its absolute strongest. It's basically a giant escape valve for the wind. So here's the simple breakdown. By letting some of that wind blast through the building instead of forcing all of it to go around, the design completely messes up that nice, neat pattern of vortex shedding. It kind of confuses the wind. It breaks up those dangerous little suction pockets before they can get into a rhythm and start rocking the building. And the result? A way, way more stable skyscraper. Okay, so the hole in the Kingdom Center is a brilliant solution for sure. But it's really just one tool in a whole toolbox of clever tricks that architects use to tame the wind. You've got all sorts of things
They can taper a building, making it skinnier at the top like the Shard in London. That messes with the airflow. Or they can soften the corners to make it more aerodynamic. That's a really subtle but super important trick they used on Taipei 101. They can even twist the whole building, like the amazing Shanghai Tower, which basically just scrambles the wind's rhythm. And if all else fails, you can put a giant weight inside the building, a damper, to literally push back against the sway. And the results are just incredible. That twist on the Shanghai Tower, it's not just for looks. It cut the wind load by 24%. That saved them a whopping $58 million in materials. And then you have Taipei 101. Inside, there is a 660-ton steel ball just hanging there. As the building sways one way, this massive pendulum swings the other, soaking up the energy and keeping everybody inside comfortable. So all these things, the tapered shapes, the rounded corners, the twists, the holes, it's like a secret language hidden in our skylines. It's this quiet, constant dialogue between human engineering and the raw power of nature. So what's the big lesson here? What can we learn from all this? I think it's this. The secret to standing tall, to building these incredible structures that scrape the sky, it isn't always about brute force. It's not always about fighting back. Sometimes it's about knowing exactly when to open up and just let the wind pass right on through.